So this is OCR's higher tier paper from June 2019. It's paper 5, the non-calculator paper. And if we have a look at the grade boundaries, then we need 24 marks for a 4, 34 for a 5, all the way up to a grade 9. Question 1, we've got some standard form work to do. We've got 2 times 10 to the 3 multiplied by 4 times 10 to the 4. Non-calculator paper, no need to go into normal numbers. Just do 2 times 4, which is 8. And 10 to the 3 times 10 to the 4 is 10 to the 7. 3 add 4 is 7. And what we get is 8 times 10 to the 7. This number is still below 10, so we're good. Completely finished in standard form. Question 2, we're just simplifying using loads of indices. So we'll look at this top row first. We're going to do 3 times 2, which is 6. A to the 8 times a to the 5 is a to the 13. 8 add 5 is 13. And then we're going to divide that by a squared. And if we just look at the a terms now, we've got a to the 13 divided by a squared. You get 6a to the 11. 13 take 2 is 11. Part B, we're just solving an equation. We've got a fraction. This is saying divide by 5. So the first step to start solving is to times both sides by 5. That would get rid of the divide by 5 on this side, and we've got 6x minus 10 equals 1 times 5 is 5. Next step is to add 10 to both sides. It's going to vanish from this side, and we're left with just the 6x. 5 add 10 is 15. Final step is to divide both sides by 6. And what we're left with is a single x. 15 divided by 6, you get away with leaving that as 15 over 6. No need to do any more, that would be full marks. If you must, you could simplify this, divide by 3, divide by 3. You'd have 5 over 2, but I'm not going to bother going to a decimal. There's no need for full marks for that. Question 3, we've got Ed, my mate, he's got a card shop. He buys a card for £1.20 and sells it for £1.68, and we want percentage profit. So I think straight away I can look at what he sells this card for, £1.68, subtract what he bought it for, £1.20. And if we do that subtraction, 8 take 0 is 8, 6 take 2 is 4, decimal, 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 and 1 take 1 is 0. He gets £0.48 profit. Now if we want the percentage profit, we need to do his profit divided by the original amount. So I'm going to do £0.48 divided by £1.20. That's quite difficult, so I'm going to look for a better calculation than this. If I times the top and bottom by 10, I'll get 4.8 divided by 12. And if I times top and bottom by 10 again, I'll get 48 divided by 120. This is still disgusting, so I'm going to try and make this much nicer. If I now half top and bottom, I'll get 24 over 60. Half again, 12 over 30. Half again, 6 over 15. Divide both these by 3. I'm going to get 2/5. Just divide by 3 divided by 3. And 2/5, well, how many 5s into 2? 5s into 2 is 0. Get some digits to work with. It's actually 0 remainder 2. And 5s into 20 is 4. All that work I know, but 2/5 is certainly much easier than 0.48 1/20. So we know that this comes to 0.4. If we times that by 100 now, we've got 40%. That is the actual answer we want, a percentage profit. Part B says that Ed's profit on good luck cards was £360, and this is a decrease of 20%. What's the original amount? So what we've got is a typical reverse percentage problem. What we don't know is the original amount, which we're going to call 100%. What we do know is a reduction of 20%. That's going to bring us down to 80%. And we know that that comes to 360. What we need to do is scale this 80% that we've got back up to the 100%. Well, if 80% is 360, I can work out 40%. Just halving left, halving right. Half of 360 is 180. I can do 20%. Again, just halving and halving, that's 90. Why is 20% good? Well, 20% is my original reduction. So that 20% is £90. if I do the 360, add the 90 back on, the original is 450. Question 4, we're talking about a sunflower growing 4 centimetres every day, and it says how many days to grow from 80 centimetres to 1.06 metres. Problem straight away, we've got different units, so let's get those consistent. 1.06 metres, to change to centimetres we're timesing by 100, and that's just going to move this decimal point 2 places, so we've got 106 centimetres. If we now look at how much the flower is growing, well, we're going to do 106 centimetres, take away 80 centimetres, you could probably do that in your head, that's 26 centimetres. And then it says we're growing 4 centimetres every day, how many days? So I want to know how many 4s go into 26. 4s into 2 is 0 remainder 2. 4s into 26, well, 6 4s are 24, so it'll be 6, and I'm just going to put remainder 2. It's going to be 6 and a bit days, and it actually says more than this, so it's got to be 7 days. Part B says if the sunflower grows at a faster rate, how would this affect your answer to part A? Well, if it's growing at a faster rate, it would take less days. Question 5, we're looking at a scatter graph. We're talking about age against value of some cars. The first 7 are plotted, and we've just got to plot the remaining 4. So here I'm going across to 3 and up to 8.0. Age is down here. So across to 3, 2, 3, 4, and up to 8 or 8.0. Across to 7 up to 5.6. Again, 2, 4, 6, 7 must be there. Here's 5. And it's not 5.1, 2, 3, 4, 5. It's got to be 5.2, 4, 6, 8, 10. So 5.6 will be 5.2, 4, right there. And across to 8 and up to 5, that's a nice one. Across to 8 and bang on up to 5. And then across to 12 and up to 0.4. Across to 12, remember we're going up in 0.2s. So 0.2, 0.4, right there. Part B says describe the type and strength of the correlation. So if we can see these crosses are kind of forming a straight line coming down, that is definitely negative correlation. And because these points are all pretty close to that straight line that I've just drawn, we're going to call it strong negative. If the points were scattered like this, but still coming downwards, we'd call it weak. Part C says one car lost its value more quickly than others. On the scatter diagram, draw a circle around that point. Well, there's clearly a dodgy point. It's got to be that one. Okay, it's further away from the line than any others. It might be called an outlier. It says by drawing a line of best fit, estimate the value of a car that is 6 years old. Well, my line of best fit is kind of okay. It should be using a ruler for this, but it's certainly in the right place. Find 6 years old. Read up to the line of best fit and across to the value. I think that's somewhere around £6.4 thousand. Remember, we were counting up in 0.2s, so 6.2, 6.4, 6.6, something like that, depending on your line of best fit. And then part E, it says explain the limitations of using the equation of the line of best fit to estimate the value of a car that is 16 years old. Well, if we moved right along here to 16 years old and focused on this line, we'd be into negatives. So I'm just going to write that down. And of course, we can't have a negative value of a car. And this is a probability tree. We're talking about red counters and blue counters. And my mate Jack picks a counter and then replaces it. Well, good news is, if we're putting the counter back in the bag, then all these probabilities are going to be out of 7. Because there's always 7 counters in the bag. If we look at these 2 branches, well, we've got 4 7ths here. This must be everything else, which is the 3 blue counters, 3 7ths there. And then these branches are just going to repeat up here. So 4 7ths and 3 7ths. And then it will be the same down here. We're going to have 4 7ths for red and 3 7ths for blue. These branches match the start. These branches match the start. Part B says work out the probability that we get 2 red counters. So we're going to travel along this branch to red, and then we're going to travel along this branch to red, And all we need to do is sweep up those probabilities as we go. That's the probability of red and red, 2 red counters. So let's pick these probabilities up. We've got a 4/7 and a 4/7, and we're working along the branches. We need to multiply those together. Multiplying fractions is easy. 4 times 4 is 16, and 7 times 7 is 49. There's your final answer. Question 7, and we've got some information about theatre tickets, and we've got normal prices here. It says £80 for adult, £40 for a child, and then there's a sale on, and these are reduced by 15%. My mate Adam's buying 2 adult and 1 child at the sale price. So there's lots of ways to do this. What I'm going to do first is just work out what 2 adult and 1 child ticket costs. Well, we've got 2 adults, so we've got 2 lots of 80, which is 160, and we've got a single child, so 1 lot of 40, which is 40. If you add those together, for those tickets, it would originally cost £200. At this point, I'm going to reduce by 15%. I could have reduced by 15% first, but I would have had to do it twice, so I may as well work out the total and then reduce by 15%. So let's find 10% of 200. We'll divide by 10, take a 0 off. That's 20. 5% would be half of this, which is 10. And that allows me to work out 15%, which is just these two added together. 10 and 5, 20 and 10, £30. So the reduction is £30. So let's figure out what my mate Adam pays. He would have paid £200. We're going to remove the 15%. The actual money that he pays, 200 take 30, is £170. It does say then that a 2% booking fee is added to the total cost of the tickets. Well, this is now my total cost. What I need to do is find 2% of this and add it on. So let's do that. 10%. Again, divide by 10, take that 0 off, is £17. I can now come down to 1%. Again, dividing by 10, I'm going to get £1.70. When I've got 1%, I can get 2%. Just double this, £1.70, add £1.70, that'd be £3.40. That is what's added on to the total cost. So what I'm going to do is 170 added to £3.40. The final amount that my pal Adam pays is £173.40. So in question 8, we've got Mrs. Mills. She's buying 4 packs of treats for her cats Fluff and Tigger. Great names. Fluff eats a 1/6 of a pack every day. Tigger eats a 1/5 of a pack every day. And we want to know how many days the 4 packs will last. Well, if Fluff eats a 1/6 of the pack in a day, and Tigger eats a 1/5 of a pack in a day, then if we add these together, we'll get how much of a pack is eaten each day. So adding fractions, we need common denominators. Let's multiply those together. We're going to get 30ths, and that's what we're going to work in. I multiplied the 6 by 5, so the 1's getting multiplied by 5. I multiplied the 5 by 6, so that 1's getting multiplied by 6. And if we add those together, 5 30ths add 6 30ths is 11 30ths. We know that she's got 4 full packs, and we want to know how many days they will last. Well, this is how much we eat per day, so we need to see how many of 11 30ths go into 4 full packs, and that's a division. How many times does this go into 4? Well, we're going to do 4 divided by 11 30ths. That's the same as 4 over 1 divided by 11 30ths. And if we're dividing fractions, we keep the first fraction, we flip the second fraction, and we change to a multiply. So we're going to do 4 times 30, which is 120, and 1 times 11, which is 11. This is how many days the packs will last for, so I'm just going to change that into a mixed number now. So if we count up in 11s, well, 10 11s are 110, 11 11s will be 121, so this is 10 full days, and then there will be 10 11ths left. So I've just converted the improper fraction to a mixed number. Let's make sure we answer the question. How many complete days? Well, complete days, 10 full days they'll last for. Question 9, we're looking at a diagram that's saying this is the interior angle of an isosceles triangle, and then we've got the exterior angle. And it says, given that Q, so this angle, is 5 lots of this angle, write the ratio P to Q in its simplest form. Well, if this red one is 5 times this one, we can just say that P is 1 and Q would be 5 times more. So we're just going to write 1 to 5. Part B says work out the 2 different possible sets of angles for this triangle. So what we're looking at is an isosceles triangle, and this here is P. Now what we do know is these angles here will add up to 180. And we know that they're in the ratio 1 to 5. We know that this one is 5 times bigger than this one. So what we've got is a ratio 1 to 5. And if we split this 180 over that ratio, well, we're going to do 180 divided by 6, and that comes out at 30. So straight away I could say, well, this angle is 30, this angle is 30, and if this is an isosceles triangle, I've got 30, 30, those 2 base angles will be the same, and 30 add 30 is 60, that would make this one 120. Angles in a triangle add up to 180, so I could say it's 30, 30, and 120. Now this bottom angle that I've worked out as 30 might not be the bottom of my isosceles triangle. What I might have is an isosceles triangle like this, where that 30 is the top, if you like. So these 2 bottom angles are the same. So what I need is to think, well, these 2 angles together would add up to 150. 150 add 30 makes the 180 in the total triangle. So I need to half that. 150 halved is 75. So my triangle could be 75, 75, and 30 as the top angle, if you like. Question 10, we've got to write 1/6 as a recurring decimal. Well, 1/6 can be seen as 1 divided by 6. So we're going to see how many 6's go into 1. The answer is 0. So we need some decimals and some digits to work with. 6's into 1 is actually 0 remainder 1. And then we've got 6's into 10, which is 1 remainder 4. 6's into 40. Well, 6 6's are 36. So that'll be 6 remainder 4. 6's into 40. 6 remainder 4. 1/6 as a decimal is 0.16 recurring. Okay, in part B, we've got my mate Elsa. She's dividing a 2-digit number by another 2-digit number, and she's getting 0.15 recurring. What this is saying is turn this decimal into a fraction. The number divided by another number is your fraction. So that's what I'm going to do first. We're going to start with x equals 0.1555. We're going to just follow this process and get 10 x's. Multiply by 10, move all the digits to the left. Again, just follow this process to turn the recurring decimal to a fraction. Multiply by 10 again, you get 15.555. And what we're looking for is this repeated pattern after the decimal point. That's a perfect match. So I'm going to pick these 2 up, and I'm going to do 100x minus 10x, and that's the same as 15.555. Take away 1.555. And what you get there, the 5's will just vanish. You're going to get 15, take away 1, which is 14. This side here, 100x take 10x, is 90x. So if 90x equals 14, then x, our original recurring decimal, will be 14 over 90. So what we've done is turn the recurring decimal into a fraction, and we can see 14 divided by 90 would be this 0.15555. Elsa's saying there's only one possible pair of numbers. Well, what that's asking is there another version of this fraction where you've got 2 digits divided by 2 digits? So we need to see if there is another pair of numbers. That definitely simplifies to 7 over 45, but that's now 1 digit divided by 2 digits. We could try multiplying top and bottom by 3, and we get 21 over 135, but that's 2 digits divided by 3 digits. I think my mate Elsa is correct. There is only one set of numbers, 2-digit divided by 2-digit, that creates this recurring decimal. Question 11, we've got some third work to do. It says simplify root 200. Well, root 200 is root 100 times root 2. The square root of 100 is 10. Root 2 is just root 2. So root 200 is 10 root 2. Part B says to evaluate, which means to work out 8 to the power of a third. Well, 8 to the power of a third is the cube root of 8. Something times itself 3 times gives me 8. The cube root of 8 is 2. 2 times 2 is 4. Times 2 again is 8. Question 12, we've got two functions just drawn as function machines. And it says we want an algebraic expression for the output for the inverse of A. So quite a confusing way to write this, but we want firstly the inverse of A. Well, the inverse of A is working backwards along this function machine. So we're going to start here and go this way along the function machine. And if we're working backwards on a function machine, we need the inverse operations. So the opposite of take 2 is add 2, and the opposite of times 3 is divide by 3. So if x starts here and travels along this way of the function machine, you're going to get x plus 2, and then we're dividing everything by 3. So we're dividing everything by 3. Part B, we've got a composite function, which is just one function followed by another function. And what we've got to do here is find the value of x, so this value here, when this is 4x. So again, it's a reverse or an inverse function that we're trying to find. So we're working backwards. We need to undo function B first. Well, function B is add 7 times 2. So if we're undoing that, we're going to divide by 2 and then take 7. So I'm going to work this way first, and I'm going to divide by 2. Well, 4x divided by 2 is 2x. And then we're going to take 7, and that's just 2x take 7. Then we're going to take this here and put that into the inverse of function A, just working backwards along function A. So we've got to do this add 2 first. Well, 2x take 7, add 2 becomes 2x. Take 7, add 2 is take 5. And then we're going to divide by 3. So I'm just going to write divide by 3. And that's what went into the function machine, 2x, take 5 divided by 3. That's what went in to create 4x as an output. Now, we're not quite finished there, because what we're actually saying is this here is the x that went into the function machine to get 4x coming out. So what we've got now is something that we can solve. We've got an equation that says x equals 2x minus 5 over 3. Well, the first step to solve this would be times both sides by 3. And we get 3x equals 2x minus 5. Take 2x from both sides, and we get x equals minus 5. There's the actual value of x that goes in. Question 13, a bit of graph work to do. We've got a straight line graph, and we said that, or we're told that this is y equals 5 to the power of x. And there's two errors. If we think down here, that is where x equals 0. So y would be 5 to the power of 0, and anything to the power of 0 is 1. So down here, when x equals 0, the graph should actually go through 1. So I'll write that down. And that's true for any graph that takes this form, y equals something to the x. It will always go through node 1. Second error, if we think about 5 to the power of 1, 5 squared, 5 cubed, 5 to the power of 4, those y values are going to get very big very fast. 5 cubed is 125. Who knows what 5 to the power of 4 is, but we're going to get big numbers very fast. So we get this curved exponential. That word exponential just means it's going to get very big very fast. Question 14, we've got a geometric proof to do. We're just proving that this triangle ABE is similar to this one, CDE. Similar means the same triangle, just enlarged. And what we've got to do is just look at the angles of these triangles. So we can look at this angle and say AEB is equal to CED. And the reason is opposite angles are equal. You might want to just say vertically opposite there. We can also look at this angle, and what we've got is a set of alternate angles there. So we're going to say BAE is equal to CDA. And the reason is alternate angles are equal. And then we can do the same looking at this and this. And again, we've got a set of alternate angles. So I'm just going to write ABE is equal to DCB. And it's the same reason as that one above. And what we've done by writing these three statements is we've got three angles that match in these triangles. So these are similar. And the reason is angle, angle, angle. If you've got two triangles where all three angles match, it has to be a perfect enlargement of that triangle, a scale factor enlargement, and that is the definition of similar triangles. Question 15, all this is explaining my diagram. It's a sector of a circle. We've got a radius of that circle, and it says the area is 6 pi. So the area is 6 pi. Show that AX, this measurement here, is 3 root 3. Well, I don't think I can do anything on this diagram until I've worked out this angle. That will often be the case. If you're given the area, you probably need to work back to the angle theta. So for a full circle, we know that area equals pi r squared. Because this is a sector of a circle, I need to multiply that by the angle I'm looking for over 360, 360 being the full circle. We know the area is 6 pi, that's given, and that is still pi times, the radius is 6, so I can put 6 squared in now. Again, I don't know the angle, I do know it's still out of 360. I can tidy this up a little bit. I get 6 pi equals 6 sixes are 36. So this becomes 36 pi times theta over 360. And we can start to simplify this. Divide both sides by pi. They'll vanish. I can do 36 divided by 360. That would simplify to 1 over 10. If you divide both top and bottom here by 36, you're going to get 1 over 10. So altogether I get 6 equals 1 theta, or theta over 10. And that would therefore tell me that theta, if we times both sides by 10, is going to be 60. So this angle here is 60 degrees. We're now looking to work out AX. So I'm looking for this measurement. What I'm going to do is just draw that triangle out again. So we've got that. We're looking for this length. We know this is 6. We know this is 60. This looks like trigonometry to me. So we've got my opposite across from the angle. The longest side is the hypotenuse. This is an opposite hypotenuse question. So if you were to write out SO, K, TOA, you'd get sine theta equals opposite over hypotenuse. I'll not write them all out, but SO is the opposite hypotenuse version. So we can use sine to say sine 60 equals question mark over 6. One step rearrangement times both sides by 6, you get 6 sine 60 equals question mark. And at this point on a non-calculator paper, I need to know what sine 60 is. I don't know what sine 60 is, so I'm going to wing it. I'm going to look for the answer that I'm aiming for. I'm aiming for 3 root 3s, and I've got 6. So there must be a half somewhere. I'm going to put sine 60 equals a half. But if that was a half, then this would become a half of 6, which is just 3. And I don't want just 3. I want 3 root 3s. So in order to get that root 3, sine 60 must actually be 1 root 3 over 2. Or just root 3 over 2. The over 2 is halving. Half of 6 is the 3. And then the root 3 is the root 3 that I'm looking for. This is just guesswork. I'm just pretending I know that, but I don't. And what you'd be left with is that. You could just wing it and probably get full marks for saying that. Question 16, we've got some circle theorem work to do. And we're looking to show angle Y. So this one is 35 degrees. That usually comes last in any kind of angles question. So let's figure out what we can do. I'm looking at a 4-sided shape. on the circle, all four corners touch the circle. And what we've got here is an angle there and an angle there. These two angles are across from each other on a four-sided shape. They're called opposite angles of a cyclic quadrilateral, and they add up to 180. So I'm just going to state that D, C, B, all of that is going to be 180. Take away 112, and that is 68. And the reason is opposite angles of a cyclic quadrilateral add to 180. I can find this angle just by what I've found, and I can label that on the diagram. This angle here is just going to be 68, take away 33, and 68 take 33 is 35. There's no real reason for that other than it's part of this whole angle, and that's the other part of it. And what I can then say is y is also 35. Reason being, we've got an isosceles triangle. Why is it isosceles? Well, that's a radius and that's a radius, so this has to be an isosceles triangle. So I'm going to say y equals 35, and the reason is base angles of an isosceles triangle are equal. For part B, I'm just going to clear my diagram and start again. And we're asked to work out angle Z. Well, we already know that these two are radiuses, so we know that this and this are 35. And what we can do is work on this triangle and say, well, if those two are 35, this here must be 180. Take away 35, or take away 70, take away both of those, and that comes to 110. And the reason for that is angles in a triangle add to 180 degrees. What we're looking at this point is now this angle in the middle of the circle and this angle at the circumference of the circle, and they both originate from BC. So if we know that this one is 110, this angle Z is going to be a half of that. So Z is 110 divided by 2, and that is 55. And the reason is that the angle at the centre is twice the angle at the circumference. Just one of your standard circle theorems. Question 17, we've got a quadratic, x squared plus 8x plus 3. And this right here is saying complete the square. Single bracket squared, take away something, is completing the square. So I'm going to do that now. I'm going to open up a single bracket squared. This x is going into it. This 8, I'm going to half, so you get x plus 4 all squared. This 4 that I've got, I'm going to square and subtract. So I'm going to subtract 4 squared. I'm going to subtract 16. And then don't forget the plus 3 on the end there. That needs tagging back on. And then we've just got a little bit of tidying up to do. You've got x plus 4 all squared. Take 16, add 3 is take 13. Part B says to sketch the graph of what we've just completed the square for. Well, if you complete the square and get x plus 4 all squared minus 13, you create something, or you can find something called the turning point. The turning point is a coordinate. We reverse the sign of this 4, so that's going to become minus 4, and we keep this minus 13. That there is the turning point of the graph, so I'm going to just sketch where that is. We might say minus 4 is there, and we might come down and just guess minus 13. Put a little cross to say you've identified that point. If we look at this quadratic that's not in completed square form, that 3 there is the y-intercept. It's where it crosses the y-axis. So I'm going to jot a little 3 there. Now all I've got to do is sketch what this graph's going to look like. It's a quadratic, an x squared graph, and it's positive, so it's going to have this U shape. We need to hit the turning point, but hit that 3 as well. So I'm going to come down, make sure I'm following a curve, hit the turning point, straight back up at that point, and hit that 3 as well. This is only 4 marks. I'm not asked to find these values, these roots. If I were, I'd have to factorise that into double brackets, but I'm not, so I'm not going to do it. That would be full marks. Question 18, we've got information about 21 people. We've got using a train, using a car, didn't use either, and using both. This question here is screaming Venn diagram. When you've got both and neither, I'm thinking Venn diagram straight away. So I'm going to draw myself a Venn diagram. On the left here, I'm going to call that train. On the right, I'm going to call that car. And then we're going to try and complete this Venn diagram. Straight away, we've got 12 add 6 add 7. Well, 12 add 6 add 7 comes to 25. That's too many people. There's only meant to be 21 people and we've got 25. And what that is 4 too many. And when you've got too many people on a Venn diagram, they sit smack bang in the middle. There's 4 too many because they've been double counted because they sit in the middle. What we can do now is adjust these numbers. If 12 use a train, well, 12 goes in all of this circle, and there's 4 of them. So this must be 8. 8, 9, 10, 11, 12. 6 use a car. Well, this circle is using a car, and there's 4 of them. This must be 2. 2 add 4 makes the 6. 7 did not use a train or a car. Well, that's easy. That's these people outside of the Venn diagram. And we'll just double check. 8, 9, 10, 11, 12, 13, 14. Add the 7, makes the 21 people that we were told in the first place. It says find the probability that when 2 people chosen at random, who used a train. So I'm looking now just at the people that use a train. I've been told that they use a train, so I'm just looking at those people. And it says what's the probability that both also used a car. So if I look at this middle bit, that's the people that use a car as well. So the first person chosen, well, the probability that they use a car is 4 out of 12. Then I'm going to choose a second person. Well, if I've already picked one of these people, there's only 3 left. And if I've already picked one of the total, there's only 11 left. I need to do 4 12ths times 3 11ths. 4 3s are 12. And 12 11ths is 132. It doesn't say simplify my answer, so I'm not going to bother. That's full marks. Question 19, we've got a cubic curve that's been drawn here. And it says use the graph to solve this thing that we've drawn, x cubed minus x squared minus 2 equals 0. Well, if we look, y has been replaced by 0. So we're looking for where does y equal 0? And y equals 0, well, here's y, here's 0. It's right there. It's where the graph crosses the x-axis. That's where y equals 0. So we just need the x value. Well, this is 1.5, 1.6789. Oh, these aren't going up in 0.1s. It must be 1.5, 1.6, 1.7, 1.8, 1.9. Yeah, I'm jumping 2 boxes. 1.5, 1.6, 1.7. Part B, quite a tough one. We've got this random equation, and it says it can be solved by finding the intersection of the graph of our graph, the one that we looked at in part A, and another random straight line. So what we're looking at is where these 2 equations or these 2 straight lines meet each other. Well, if the lines cross over, then their y values are the same. And if their y values are the same, we can write this. Our graph, x cubed minus x squared minus 2, will be the same as ax plus b, this other one. If those graphs cross over, their y values are the same. I can write that these 2 are the same as each other. What I want to do now is look at this random equation I'm trying to solve. Someone has started with this and rearranged it to make it equal 0. So I just need to see what they've done to make this right-hand side equal 0. Well, they've got the x cubed that we've got. That's fine. They've got the minus x squared that we've got. They've got minus 6 and we've got minus 2. So they must have taken 4 away, which means they've taken 4 away, which means this b must have been positive 4. If we look at what else they've got a plus 5x and we don't have any x terms. So they must have added 5x, meaning they've added 5x, meaning to get this to 0, this must have been minus 5x. So a must have been minus 5. This other straight line that they're looking at must have been y equals a is minus 5 and b is 4. If we go to part 2, it says use our graph to solve their random equation. Well, we've already been told that we can do that by looking at where the line that we've just found crosses our graph. So let's have a look at this line again. The line was y equals minus 5x plus 4. I'm going to use a shortcut method of drawing this. This here is my y-intercept, so I know it's going to go through 4. And a gradient of minus 5 means for every 1 across, I come down by 5. So that's what I'm going to plot. I've used a gradient intercepts method. 4 is the y-intercept. Gradient is minus 5, meaning for every 1 across, 5 down. I could do another 1 across, 5 down, but I'm going to go off the page. I'm going to join these together. And that is the line y equals minus 5x plus 4. If I'm solving the equation, I'm looking for where they cross over, which is here. Just read up to your x solution. I think it's 1.2, something around there, 1.2, 1.25. It does say to 1 decimal place, so 1.1, 1.2, 1.3, probably full marks.